Hello everyone. So in the previous videos we have completed chapter 12, so we'll start with chapter 13, determinants and matrix inversion. So you must have studied determinants and matrices in your class 12th as well, but this would be a slightly advanced version, but it is very scoring. Okay, so starting, basically what is a determinant? Determinant is a number which is associated to a square matrix. So you should know that it is associated to a square matrix. So the order should be n cross n. It should not be 3 cross 2 or 4 cross 2. So the order should be n cross n. Now, determinants of order 2. This is 13.1. In this video, we'll be covering 13.1 only. So given the system of equations, this system of equation, the A matrix, which considers the coefficients only, is given by a11, a12, a21, a22. Now, geometrically, each of the two equations represents the graph of a straight line, because these are linear equation, they represents graph of straight line. So if this result is important, if a determinant is not equal to 0, that is, this determinant is not equals to 0, then the two lines intersect at a unique point. So if a determinant is not equals to 0, then these two lines would intersect at a unique point, and hence it would be a unique solution. On the other hand, if a determinant equals to 0, then two cases exist. First is that the lines are parallel. So in this case, there would be no solution. The second case is that the lines coincide. In that case, there would be infinite solutions. Okay. Now moving forward, you must know this formula by now. A determinant equals to product of the diagonal minus product of the off diagonal elements. So this is for 2 cross 2 when the order is 2. So a11, a22 minus a21, a12. Now Cramer's rule is important. So so given this set of equations, you can find the value of x1 when this is determinant of this. This is also determinant of this matrix. So x1 can be found as, so we know a was a11, a12, a21, a22. Now, given this set of equation a11 x1 plus a12 x2 equals to b1, a21 x1 plus a22 x2 equals to b2. So given this set of equations, we can find a determinant at and x1 is, so we will replace this column with a12, a11, a21. So it is b1, b2, a12, a22, and the determinant of this. So this would be the value of x1. So basically replacing the first column, because we want to find for x1, with b1, b2. So we'll get the value of x1. Similarly, for x2, we'll replace the second column. So x2 would be this thing. a11, a21 is as it is, and then b1, b2 would be replaced from A matrix. Okay, so let's do a question which will make things more clear. Solve this equation using Cramer's rule. So with these equations, we know A equals to 2, 2, 4 minus 2, and B equals to 7 minus 2. So using the Cramer's rule, we know x1 equals to b1 B2, A12, A22. Determinant of this upon determinant of A. And x2 equals to A11, A21, B1, B2 upon determinant of A. Now, determinant of A would be determinant of 2, 2, 4, minus 2. So this gives us 2 into minus 2 minus 2 into 4. This is minus 4, minus 8, minus 12. So determinant of A is this. X1 would be B1, B2 is 7, minus 2, then 4, minus 2 upon minus 12. So this turns out to be minus 14 minus of minus 8 upon minus 12. This is minus 14 plus 8, which is minus 6 upon minus 12. So this comes out to be half. Similarly, we can find for x2. x2 would be A11, 2, 2, 2, 2, then 7 minus 2 upon minus 12. This would be minus 2 into 2, minus 4, then minus of 7 into 2 upon minus 12. So this is minus 4, minus 14 upon 12 upon minus 12, minus 18 by minus 12. So this cancels out. So x2 is coming out to be 3 by 2. So we have x1 as half, x2 as 3 by 2. So in this paper, if you are solving this, it will take just another minute to verify your answer. Just put these values back into the equation and check whether it is being verified or not. So 2 into half plus 4 into 3 by 2. So 2, 1 plus 6, 7. Okay, so this is verified. You can check for the other equation as well. 2 into half minus 2 into 3 by 2. So this cancels out. 1 minus 3 minus 2. So both these equations are satisfied. So we have this as the solution. And in case if A determinant was coming out to be 0, then we know either the lines are parallel, they are parallel so that no solution exists, or else they are coinciding. In that case, there are infinitely many solutions. Okay, now let's do another example. Using Cramer's rule, find find Q1D and Q2D in terms of the parameters when this equation is given to us. Okay, so what we have is the A matrix is given by 2 B plus beta 1 B 2 times B plus beta 2. The B matrix is given by A minus alpha 1 A minus alpha 2. Now using Cramer's rule, we can find the value of Q1D, which would be B1 B2 A12 A22 upon A determinant. So A determinant, if we have A this, so A determinant I'll solve here. A determinant would be 2 times B plus beta 1 into 2 times B plus beta 2 minus beta square minus B square. This would be 4 B plus beta 1 B plus beta 2 minus B square. So if this is not 0, this won't be 0, because if beta 1 and beta 2 are positive, then this won't be 0. So we know that they would intersect and we will have a unique solution. So I'll put A determinant equals to, suppose, okay, so this is the A determinant. Now Q1 would be b1 b2 is a minus alpha 1, a minus alpha 2, sorry, a minus alpha 1, a minus alpha 2, then b 2 times b plus beta 2 upon a determinant. So if we'll solve this, this would become a minus alpha 1 times 2 into b plus beta 2 minus b into a minus alpha 2 upon a determinant. So this is the value of q1d. Similarly, q2d would be 2b plus beta 1 b upon a determinant, and then the coordinates of beta. Okay, so if we'll solve this, so I'm giving you a minute to solve this on your own. Oh, so this is basic, so you should know how to solve the determinant for this. Okay, now moving forward, so this is a bit important part. So the geometric interpretation of a determinant. So this is of order 2. Now if you're considering a determinant of order 2, ideally we want to find this area, denoted by T. Now, so this we have done in the vectors as well. This is a parallelogram. So we need to find the area of this parallelogram. Okay. So these are the two vectors in the matrix a11, a12, a22. So this is the first vector, this one, and a21, a22 is the second vector. Now we have got the parallelogram. Now to find the area, right? So the whole area including the dotted part would be equals to length into breadth. So this is a rectangle from here till here, and then so this would be equal to a12 plus a22 times a11 a21. So this is the right hand side. So this is the area of the rectangle. Now the area of the rectangle can be subdivided into different parts as well. First is the capital T that we want to find, then 2 times T2 because they are congruent, then 2 times T3 and 2 times T1. So 2T1 plus 2T2 plus 2T3 plus T should be equals to the total area of the rectangle. Now let's find what T1 is. So T1 is this area, right? So the height, so this is a rectangle, the height is a12. So a12 into the base. So this base is a11, this is a11 plus a21. So this would be a21. So this is what we are having as T1. Now looking at T2. So we have found base is a21. So T2 is a rectangle, so it would be half into base into height. Now the total height is a12 plus a22, and this much height is a12, so this much height would be a22. So the area of T2 would be half into a21 into a22. So this is the area of T2. Now looking at T3, this height is, so this is a22, this total height, and this total the remaining height would be A12. So this is A12. And if this distance is A21, then the remaining distance would be, look at this, it would be A11. So half, T3 would be half into A11 into A12. So this is the T3. Now with the help of this, we can find what the value of T would be. So value of T would be, okay, solving this first, this is A11 A12 plus A11 A22 plus A21 A12 plus A21 A22 minus 2 times T1 minus 2 times T2 21 A22 minus 2 times T3 A11 A12. This cancels out. So we are left with A21 A22. This cancels out. Okay, so this negative, this would cancel out. And A11 A12, this also cancels out. So what we have is A11 A22 plus this, these are same thing. So this is minus 2. So this could be minus A12 A21. So if you will see, this is the determinant for a matrix. The determinant of this is nothing but this same thing. So we have geometrically derived the determinant as well. Okay, so one last question before we end the class. Consider the following linked macroeconomic model of two nations, I equals to 1, 2, that trade with each other. So you must know this equation, y equals to c plus I plus g plus nx. Now in this case, g is assumed to be 0 and there is no I as well. Okay. Now y1 equals to c1 plus a1 plus x1 minus m1. This is net exports. C1 equals to small c1 into y1, where c1 is small c1 is marginal propensity to consume, and m1 is marginal propensity to import. So this would mean if your income increases by 1 unit, by how much more will you import? Okay, moving forward, similarly, this is for nation 2. Here I equals to 1, 2, yi is income, ci is consumption, ai is exogenous autonomous expenditure, xi denotes exports, and mi denotes imports of country I. Now, first part, interpret the two equations, x1 equals to m2 and x2 equals to m1. So x1 is the exports of country 1, exports of country 1, and m2 are imports of country 2. So what happens is, basically, since there are only two nations, what the first country is exporting is this would be the same value, and in would be the same value of what the second country is importing. So the exports of country 1 would be equal to imports of the second country, because there are only two countries. Similarly, the imports of country 1 would be exports of country 2. So this is the interpretation for it. Now look at the second part. Given the equations in part A, calculate the corresponding equilibrium values of y1 and y2 as a function of the exogenous variables. Now, since y1 is c1 is c1 y1 plus a1 was exogenous plus x1 is also exogenous minus m1 y1, and y2 can be similarly written as c2 y2 plus a2 plus x2 minus m2 y2. So we have got these equations. This is the system of equation that we have found. Now, so this is okay. So x1 was m2, because it was already mentioned that x1 is m2. So this would become, since x1 is m2 in equilibrium, so it is m2, and m2 is m1 into m2 into y2. So plus m2 into y2. Similarly, x2 equals to m1, which is m1 y1. So plus m1 y1. So solving this, y1 1 minus c1 plus m1 minus m2 y2 equals to a1. So on solving this particular equation, substituting the values and solving this, we have found this. Similarly, on solving this equation, we have y2 1 minus c2 plus m2 minus m1 y1. Okay, so these coefficients should be here. It is not a big deal. So it would be minus m1 y1 plus 1 minus c2 plus m2 times y2. So this should be equals to a2. These are the two equations that we have, and the two variables are y1 and y2. a1 and a2 were exogenously determined. Now calculate the corresponding equilibrium values of y1 as a function of exogenous variables. Now we have is, so y1 would be equals to, so using the Cramer's rule, we can solve for, since there are two equations and two variables, we can solve by substituting as well. But suppose we use the Cramer's rule, it would be, before this, the A matrix, A determinant is 1 minus c1 plus m1 minus m2 minus m1 1 minus c2 plus m2, and B is a1 a2. A determinant would be 1 minus c1 plus m1 into 1 minus c2 plus m2 minus of minus m1 minus m2. So this cancels out. So it is 1 minus c1 plus m1 into 1, then minus c2. So let's solve it again. Okay, so the first component multiplied by everything, 1 minus c2 plus m2, then minus c1 plus c1 c2 minus c1 m2 plus m1 minus c2 m1 plus m1 m2 minus m1 m2. So we'll see that this things cancels out. Okay, the remaining everything would remain. So this is A determinant. So y1 would be b1 b2 into a12 a21 upon A determinant. So this is nothing but, also this is nothing but b1 is a1 a2, this is minus m2 1 minus c2 plus m2 upon A determinant. If we'll solve this, this is coming out to be a1 minus a1 c2 plus a1 m2 minus of minus plus a2 m2 upon a determinant. So y1 is coming out to be this. Okay, now moving forward, similarly we can find the value of y2 as well. Y2 would be a11, a21, b1, b2 upon a determinant. So a11 was this thing, 1 minus c1 plus m1 upon not upon, this is b1 b2 or a1 a2, a1 a2 upon a determinant. So this was coming out to be we'll solve this. This is a2 minus a2 c1 plus m1 a2 minus of minus, so plus m1 a1 upon a determinant. So this is the value of y2 that we are getting. Now looking at the last part of the question, how does an increase in a1 affect y2? Interpret your answer. So in economics, this interpretation is the most important thing when it comes to MME. You need to able to interpret these things as well. Now this is y2, so del y2 by del a1, this would be m1, and since a determinant is this value 1. Okay, since c1 c2 m1 m2 all lies between 0 and 1, this product would be very small number, this would be very small, this would be very small. Okay, and it is expected that a determinant would be greater than 0 only, because 1 minus very small digits and there are some positive signs as well. Okay, so a determinant is positive and it would depend on the sign of a determinant. If it is positive, then if a1 increases, so the first derivative tells that if a1 increases, y2 would also increase if a determinant is positive, and if a determinant is negative, that would mean if a1 increases, then y2 should fall. But what was a1? a1 was autonomous expenditure. We had the equation y equals to c plus, there was no I, c plus a1 plus x1 minus m1, c1 plus a1 plus x1 minus m1. Now if a1 increases, or the autonomous expenditure in country 1, then y1 would also increase, because a1 is a component of y1. So if a1 increases, this means y1 also increases. Now since y1 has increased and imports is also dependent on y1, अगर कंट्री की इनकम इंक्रीज हो रही है तो दे विल import more, and now if they are importing more, the exports of the other country would increase because it is equals to the import of the first country. And if x2 increases, then we have c2 plus a2 plus x2 minus m2, and if this is increasing, y2 would also increase. So if a1 increases, indirectly we will know y2 increases, and this process will keep on occurring, because if y2 is increasing, then imports from country 2 would increase. That would lead to increase in exports of country 1, then y1 would also increase. So you will study in the international trade, these are the foreign repercussions. Okay, you, even though इसका भी formula derivation नहीं आएगा, but this is how things work. And you can expect these types of questions coming in your exam. Okay, so in the next video, I'll start with 13.2, and since 13.3 is not part of your syllabus, so we won't do this. We'll stick to 13.2 only. Okay, thank you.